Now next we have is gold leaf electroscope. It consists of, as I've made a figure for you. What does it has? It has a glass case, as you can see. It is placed on a wooden plate. This we have a brass disc from which a brass rod passes. This is an insulating plug, and this brass disc is also called as brass cap. So from brass cap there is a brass rod which is entering into a glass case, and this brass rod has two gold leaves, as you can see at the end. This is what is a gold leaf electroscope. Now how it is used to know like what function it can actually do. It can actually tell us that whether the body is charged or whether the body is uncharged. Now how? It can, because see, what we'll do is we'll bring a charged body. Suppose I'll bring a charged body. Let's say the charged body is positively charged. I'm going to bring this charged body and I'm going to touch this brass cap with the charged body. So what happened when it is touched, then due to conduction, the charge from this charged body will flow from brass rod to gold leaf because it is positive charge. So they will also acquire a positive charge, both leaves, and they will repel each other and the leaves will diverge. Right. So if there is a divergence in the leaves, so that means this body which you are bringing is a charged body, because the charge is transferred from this to both the gold leaves, because they acquire the same charge. That is why they move apart. But if in case it is uncharged, let's say this is uncharged. Then what happened when it is uncharged and it is brought near? So no charge flows from here to gold leaf, and gold leaf will not acquire any kind of charge. So leaves will be closer to each other. That means there is no divergence. So this actually proves that which body is charged or uncharged. So you can write here how we come to know. If first you need to touch. First we touch the brass cap. We touch the brass cap with the body to be tested. So what we see, if the leaves diverge, that means body is charged. But if leaves do not diverge, that means body is uncharged. And you know that why the leaves diverge? Leaves diverge because they acquired the same charge, and because due to repulsion they will move away. But if the body is uncharged, there will be no flow of charge and the leaves will remain as such. So this is how you can know that body is charged or uncharged. Second thing, we can actually know that the substance to be tested is a conductor or it is an insulator. We can actually know this also. So how we can know this? So what we do is suppose this is an electroscope, two electroscopes we have. I'm going to charge one of the let's say this is A electroscope, this is B electroscope. Let us charge the electroscope A by conduction. So what I do is I bring the glass rod. Let's say, because we know it is positively charged, I bring the glass rod, I rub the glass rod with silk, and this charged glass rod is touched with the brass cap. So as a result it will acquire a positive charge, right, and leaves will diverge as they are already diverged. And now what I'm going to, but this is uncharged, so that means leaves are like this, right. Now I'm going to, I have a body which need to be tested, that body is conductor or not. So this body is to be tested. And this is my already acquired this positive one. So what I do is I connect these two electroscopes with the help of this this body which is to be tested. So what I see is, and it is like this. So what happened, if this body is conductor, then that means some of the charge will flow from this to this place. So if it is conductor, then what we see that the leaves of B electroscope also diverge, because they also acquire a same charge, because the charge positive flow from this body to this body, because if it is conductor. But if it is insulator, and let's say this electroscope was like this as it was present earlier, let's say if it is an insulator, so that means it will not allow the charge to flow from here to here and leaves will remain as such. So that means if you see the divergence in the leaves of electroscope B, that means the body to be tested is conductor, but if there is no divergence, that means body to be tested is insulator, because when it is conductor, then only it allows the charge to flow, and the same kind of charge is going to flow. And as I made this positive, I can also make it this make negative also, because we just need to know that a body which is to be tested is charged or which is conductor or an insulator. So if it allows the same kind of charge to flow through it and the leaves diverge, that means it is a conductor. But if it doesn't allow any charge to flow, so that means this is an insulator. So we can know this also. Now we can, one more thing we can know, we can actually know the nature of charge also. We can actually know the nature of charge on the body to be tested also. Let's say I have charged this my electroscope, I have touched with the glass rod and it has acquired a positive charge. Let's say this is in positive charge, leaves diverge. Now I am going to bring, let's say I am bringing a body closer to it. Let's say this is positive charge. Right. So when I try to bring a body which is to be tested, let's say this is my tested body whose nature of charge is to be tested. I bring the charged body and I touch it with brass cap. So what happened? If the leaves diverge more, if the leaves diverge more, that means if the divergence increases, that means the body has same kind of charge as of gold leaves. But if I suppose if it is, again I have made it positively charged and this body is to be tested, but this is negatively charged. So if I try to bring if I bring a body to be tested, a charged body, a nature of charge is to be tested closer, and I touch the brass cap, if the divergence decrease, if divergence of leaves decrease, that means this body has an opposite charge. This body possesses an opposite charge, like it is positive, so that means if the divergence decrease, so that means the body whose charge is to be tested is negatively charged. So this is what is a gold leaf electroscope, and by this we can actually see that whether the body is charged or uncharged. How? We need to touch the brass cap. If the leaves diverge, that means this body is charged. If there is no change in the leaves, that means they are as such, so that means body is uncharged. Second, we can know the conductor or insulator. For this you need to prior charge your electroscope, one of the electroscope, then connect two electroscopes with that material which is to be tested. If the leaves of the electroscope B also diverge, that means it is a conductor. If there is no change, so that means it is an insulator. Third, again we want to know the test, we want to know the nature of the charge on any body. So we need to prior charge it. So if we bring the body which is to be tested here, and if the leaf diverge more, so that means it possesses the same charge, and if the divergence decrease, that means it possesses an opposite charge, that body. So this is what is a gold leaf electroscope, and I think because it is you can say a type which has more advantage over pitfall, because it can actually tell us more accurately and it can tell us about a conductor and an insulator also. So this is what is a gold leaf electroscope.